we've already configured the duct static input. We'll configure the return air temp to read as temperature. We'll have a couple AVs for our base heating and cooling set points. We'll interlock both sequences to make sure the fan is running and that the return air temperature sensor looks reliable, not shorted, not open. Then we'll actually do 3 stages of cooling to let the economizer work first if the outside conditions are good before going to mechanical cooling, and then the heating sequence will do 2 stages of heating. So going back to ASI Expert, we'll add a group with the right click on the left side, add group. I'll give it a name like cooling and heating. I think the ampersand character shift 7 is actually okay, but just to stick with the letters, numbers, spaces, dashes, underscores, I'll just type out the word and. Click OK. Sorts alphabetically in my list. And then I just need to start dragging out the appropriate icons. So I'll start with the input object, IMP. I should have an instance named return air temp. Notice there's a little icon next to the name. If you see the green, blue, red, and yellow squares, that means that instance has been used in at least one other group. And in this, excuse me, the reserved column, it shows one of the groups it's been used in. If you see the question mark, that means there's some level of programming that's been entered for that instance, but it's not yet been added to a group. It could be something as simple as setting index enable or entering a name. So that doesn't necessarily mean it's actually really being used for actual, programming and control purposes. And then if there's no icon, like you might see in the logic, if it's just a white space next to the name, that means that the instance is completely blank. Nothing's been changed from the default 0 values, and it's not been added to a group yet. Normally, I don't like to use a single icon or a single object instance in more than one group. And that's mainly to avoid kind of changing the programming of the controller. I don't mind so much with inputs because they're essentially read-only in that there's no input handles from the left. So in this case, I'm going to go ahead and drag duct static out again, even though I previously used it in my fan control group. I'll then go to the sequence object, SEQ, and sequence instance 0 will be for cooling up top. Sequence instance 1 will be below for heating. I need 2 separate sequences because we can only, stage up for cooling or heating, not both within the same sequence. There's a couple of logics that I will want to add. One to check fan status, one also to check to see if there's any problem with the return air sensor. So I'll go to LOG for logic, drag the 0th instance near duct static, and instance number 1 further to the right. And then there's a couple AVs for the base set points for cooling and heating. So I'll go find the AVL analog value object. Instance 0 is reserved for the duct static set point, so I'll take AVL instance 1 near the upper sequence and AVL number 2 near the lower sequence. And then finally, I have 4 relays, 2 for cooling, 2 for heating. Those are in the output object OUT. And cooling 1 and 2 near the upper sequence, and heating 1 and 2 near the lower sequence. There's a few of these, the ones in the middle that have the red circle with the slash. So you can enable those individually or as a group. And so then I enable those. So I'll give you a minute to get your icons out on the screen, kind of situated, similar to how mine looks. So it's 2 inputs, 2 logics, 2 AVLs, 2 sequences, and 4 outputs. So that 2, 4, 6, 8. There's actually 12 icons I have on my screen right now. How's everybody doing with their icons?
Good to go.
Good. Okay. So I like to start with the inputs to make sure that they're reading correctly. So duct static, we've already configured that one to scale it as a pressure. So return air temp is new. So I'll go to the return air temp properties. And it's already been named. It's already been given the input type of analog, which is good, but analog inputs need a convert type. So if I click on convert type where it says raw, then if you were to buy thermistors from us, we sell 3K thermistors, which means the resistance is 3,000 ohms at 77 degrees Fahrenheit. So all these ones that start with T are all for 3K thermistors. And so there's some differences. The ones that have C in them, those are for Celsius, which you don't want those. And then there's T1 and T2. And the T1 is for use with an input that has a 3.32 K ohm pull-up resistor, which is the default for all inputs on an ASIC 3. Some of our older controllers had some inputs that had a 1.82 K pull-up resistor as a default. So that's what the T2s are. And so then once we've narrowed it down to T1 or T1F0, the difference is this no self-heating kind of description. So I'm going to temporarily, well, I'll select T1F0, no self-heating, because that's actually the one I want. And then I'll go to the documentation and tell you why. So I'll click T1F0. So that means it's a 3K thermistor, no self-heating in Fahrenheit with a 3.32K pull-up resistor. Click OK. Gives me the shorthand T1F0. And let's just close my help files so that we can start fresh in case you want to open yours fresh. So I'll go to help ASIC 3, obj underscore ASIC 3. The object 5 is for inputs, and input operation, analog input convert types. Here's this one that says 3K thermistor input conversions without self-heating. And what it says up here is analog input convert types without self-heating compensation for use with insertion type 3K thermistor temperature sensors. So insertion type I interpret to mean duct or well sensors. So this would be a duct sensor. So it doesn't make a huge difference compared to the one without the with no self-heating versus the regular one. It's maybe a degree and a half difference. So again, it's not a huge difference, but it should be slightly more accurate if it's a duct sensor if you choose the without self-heating option. And so we can see here the default value when nothing's connected is very low. If you look at a thermistor curve, a high temperature is a low resistance and a low temperature is a high resistance. And so with nothing connected, it's basically an infinite resistance. So it's showing a very low temperature of about minus 40 degrees. If you were to short the input, it would show something normally above 200 degrees. And so we can kind of use those readings to determine if the input is open or cut. or shorted, because the return air temperature never should get to be sub-zero, and the return air temperature should never really get to be 200 degrees either. So if we see those values, we can know that that means there's probably a problem with the wiring somewhere. And so on this Alarms and Limits tab, there are checkboxes for high and low alarms and high and low limits. And they're similar, but there are some differences. So I'm going to end up using the limits, but I'll show you how the alarms work first. So if I enable the low alarm with a low alarm set point of 0, notice it goes into low alarm because the present value is lower than the low alarm set point. If the present value was higher than the high alarm set point once enabled, then we would get a high alarm status. So we could use that, but instead I'm going to use the low limit and the high limit options. So when low limit enable is yes, if the measured present value would be less than the low limit set point, then we get a low limit fault. That's very similar to the alarms. However, the present value gets limited to whatever the low limit set point is. There's actually a little alignment issue I'm going to ask them to fix here. Let's see, alarms and limit tab for input, high, low alarm status boxes should be higher. So I'd prefer to see these kind of aligned or just ever so slightly lower. It's a minor thing, but I like to point them out when I notice them, especially this is a relatively new release, so we can change some things before we publish it. So when the measured value would be lower than the low limit set point, then we show the low limit fault and we cap the present value at the low limit set point. But the main reason I like to use the low limit or the high and low limits to check for a problem with the wiring is there's this fault status parameter which turns on if there's a high limit fault or a low limit fault. Because I don't really care if it's shorted or open. I just care that I can't trust the value anymore. So then I can write my program to look just at one setting. So I could say if there's a high limit fault or there's a low limit fault, then block out the sequence. But for me, it's a little bit easier to just say if there's a fault status, block out the sequence. It's one less thing I have to look at. And so the high limit fault is probably as you would expect. If the measured value is higher than the high limit set point, then there is a high limit fault and the fault status also goes into fault. So just to show you that, I'll temporarily change my low limit set point to -6,000. So that clears the low limit fault because the measured value is not lower than that. But if I set the high limit set point to like -5,000, now the measured value is higher than the high limit set point. So we cap it at the high limit set point and the high limit goes into fault. So now we've seen that if there's either a high limit fault or a low limit fault, then the fault status goes true. So that's all to check to see if we can trust the values. So more typical values I would use for a high limit set point would be like 200 degrees, which is 20,000. It's 200 with 2 extra zeros for the 100th of a degree. And then the low limit, quite often, unless it's something like outside air temp, I usually just enter it as 0 because most temperatures, except for outside air temp where it's quite cold, your temperature values aren't going to be lower than 0. So we're going to set those. There's also, for BACnet systems, there's this BACnet alarm and COV tab. And the most important value I want to point out here is this notify COV increment. So COV stands for change of value. And when we're connecting to a BACnet front end like IntelliFront, it will by default use COV subscriptions as it's reading values from points. So it's not kind of constantly checking the value. It's going to subscribe to the point, and when it changes by the COV increment, then that will cause the value to update on the front end. So the default is 1, meaning 1 degree. if I wanted the value in the front end to update when the value changed, by a smaller amount, I could set this to, like 1/10 of a degree or 1/2 a degree. So I'll just put in 0.5. So now if the temperature changes by at least 1/2 a degree, then the value in the front end would update. And we'll see that notify COV increment on both analog inputs and the analog values themselves. And I think we see them on analog outputs too. So that is there. And this binary backnet alarm, I think that actually shouldn't be shown either since it's an analog point. So I'm going to ask about that. Binary backnet alarm tab shown for analog input question mark. Okay, so then going back to the graphical programming, I can click on the name of my group for cooling and heating. Now that that return air temp is reading in 1/100 of a degree, I can link its value to both the input for the upper sequence as well as the input handle for the lower sequence. And then going back to the slides, now I'm going to do this logic. I want to make sure there's at least some minimum level of pressure before I allow the heating and the cooling to run, so that if the fan's broken, I don't turn on the cooling and heating outputs. So we're going to use the logic object. Oops. We're going to use the logic object here. And so there's all kinds of different logic types. And so this type is AI/BO, means there are analog inputs with a resulting binary output. And the binary output will turn on, in this case, if the A value, which is the upper value, GT means is greater than the B value, which is the lower value.
AIBO.
And it's what we call a signed comparison, which means negative values are allowed. And in general, when you're given a choice of signed or unsigned, my advice is to choose the signed option, because otherwise, if you ever see a negative value, it won't get handled correctly. And so there's a few cases where you have to use unsigned values if you're dealing with some very large positive values, but it's not as common. So that logic type, I can change it because the default logic type is not correct, doesn't match, right? This is binary inputs with the resulting binary output. So that's not what I want here. And to change the logic type, one way is to just right click on the center of the logic icon to get the right click menu. And then all the way at the bottom of the list, it says logic type. And then if you slide over, it'll show you a bunch of different logic types. So I actually want the first one in the list that starts with AI/BO, because that's the AGTB. GT meaning greater than. There are other options like GE for greater than or equal to. EQ means equal. LT means less than. LE means less than or equal to. But I want AI/BO, AGTB signed. So I choose that. The icon changes a bit just to tell me that the A handle is the upper one. So I'm going to connect that A handle to the value of my duct static icon. And then it'll show me the value. And then to get that little gray box coming out of the B handle, just like we did for the remote schedule, you could just right click from the B handle and drop it on the red pound sign that appears above the icon. So I'll right click and drag from my B handle, drop it on the pound sign, and enter that value of 50, meaning 1/2 an inch, because my duct static input is in 100ths of an inch. Everybody get the gray box? I didn't hear any objections, so I think that means everybody's okay.
I got the gray box, but mine's at 0.
When you dragged and dropped, it asked you to enter a value, so just type 50 on your keyboard, and then your gray box should have a value of 50.
All right, thanks.
Yep. And so then if you go to the properties of that logic icon, you can give it a name like fan status. And then there's also this setting called hysteresis unsigned, and that It's kind of like the, where did we see? We saw hysteresis in one other part of this group, did we not? Or maybe we didn't. Oh, it's for the notify, yeah. So it's like the hysteresis for the notify. And so what it ends up meaning is if the A value is greater than 50, then the logic turns on. And then if the A value drops below 50 by the hysteresis amount, then the alarm will clear, or the binary output will turn off. So if I enter like a value of 20 there in hysteresis unsigned, then that means above 50 or half an inch, the logic turns on. If it drops below 50 by 0.2 inches, so if it goes to 0.3 inches, then the binary output will turn off. And that's there just to prevent the output from toggling from off to on if you're right at that point. So for analog comparisons, it's usually a good idea to set the hysteresis. And so I can go back to the graphical programming group. And then the second logic type is a binary input / binary output logic type. So that I'm going to have two binary inputs and the binary output will turn on if the A value is off. Not A means if A is off, and the B value is on. So I want it to turn on if my return error temp is not in fault, meaning no wiring errors, and fan status is on. So I can change that logic type by right-clicking on the icon, logic type, and carefully review your BIBOs to find the one that should be like fifth from the top, BI/BO, not A and B. So that means the output turns on if the A handle is off, meaning 0, and the B value is on, meaning non-zero. So I can connect the B handle, the lower B handle, to the fan status. And then I can connect the A handle. I want to connect it to the fault status of the return error temp input, which doesn't have its own dedicated landing point. So that's where I can link to the arrow and then choose it from the list. So if I right click and drag from the A handle of this logic to the arrow for return error temp, then it gives me the list. If I scroll down just a little bit, then between high limit fault and input OR status is the fault status. And that's when we saw it turns on if there's a low limit fault, meaning the wire has been cut or there's no sensor connected, or if there's a high limit fault, which means the input is shorted. Did everybody find fault status in the list?
Yes.
Okay, good. I'll click OK. I'm going to just move these icons around a little bit so the lines don't cross over quite so much. And then I can rename that logic instance to match the slide where it says check RAT fault. And you can either go to the properties view and enter the logic name, or for binary logic types, you can actually just right-click on the icon and select rename and type in the name without even going to the properties view. You can actually change the name for any logic type with right-click rename. I like to go to the properties view because that reminds me to set the hysteresis amount. So there's my value. I can then take the result of that RAT fault and link it to the interlock handle of both sequences. I get these lined up a little better.
Hey, Mike, where did you know to put the hysteresis in?
That was in the fan status properties for the analog comparison. So if I right-click properties on the fan status, that says hysteresis unsigned. So there should be one logic instance, which is an AI/BO, AGTB signed, and then I just set the hysteresis to 20, meaning 2/10 of an inch. Do you see that in your controller? Looks okay. All right.
Yeah, it should be good. Thank you.
Okay. So now I'm going to put these base set points in. When I have multiple stages for sequences, I like to have one base set point that's adjustable from the front end so that all the set points shift together. You can have individual set points for each stage, but I've found that that's not so user-friendly because the users won't tend to keep them with, the same offsets. So the upper AV here, I'm going to call the cooling set point. In the slide here, here's cooling SP. It's linked to a value of 7400, meaning 74.00 degrees. And then the heating set point is going to have a base set point of 7200, meaning 72 degrees. So from the upper AV, I'll just drag from that left handle, drop it on the pound sign, enter 7400. And then the lower AV, I'll do the same, but enter 7200. That should be the values you see in the gray boxes. Then I'll go to the properties view to give them names, units, and scaling. And in fact, there's an increment amount there too we can set. So if I go to the upper AV for 7400, go to properties view, I can give it a name like cooling SP. I want to get the decimal in the right place so that the real value is 74.0. So I can put a check in the box for scale enable, set the scale factor to 0.01, and then the real value should show me the decimal in the right place. And then backnet unit, I can also set to degrees Fahrenheit. And so if I click on the backnet unit, I mentioned that you'll probably find it helpful to just click on one of the entries and just hit the first letter of the units you're looking for. So I'll just click on one of the units and press the letter D on my keyboard until I see degrees Fahrenheit. So I'll get past Celsius and Kelvin, and then Fahrenheit is next in the list. And then there's that same COV increment that we can change on the backnet and alarm and COV tab. So this notified COV increment, we tend to default to 1, and depending on how they're changing the set point, you might want to set that to a lower amount, maybe as little as 1/10 of an inch. You can put in 0.1. And then going back to the graphical programming view, you could do something similar for the heating set point. So that's this lower AV, right-click properties. Does it look happy? So what I expect is going to happen here is my program's going to shut down. And since I hadn't saved the program recently, I'm not going to see all the graphical programming when I reconnect. But when I start dragging things out, any connections that I show, look at that. There's a suspicious action. My security software didn't like that. That's pretty weird. So let me go and restart. See what I get. Never seen that happen before. Shut down based on my security software. So I'm just going to open my October 26 training project. Security activity has occurred. Let's see if it lets me discover. So that's good. Mine was what, 9505. There it is. If I go to functions, I probably won't see my latest function, but I can quickly rebuild it. The lines will draw and we'll proceed. So cooling and heating. I got a couple inputs called return air temp and static. I have a couple logics like fan status And notice the lines draw because it knows they're connected in the controller. I have a couple sequences. And I have a few outputs. And I have a couple AVs.
Hey, Mike, can you slow down for a second? My computer just locked up and everything just went down, and I'm coming back up. And unfortunately, my sequence didn't save after I started the build, so I got to rebuild it.
Yep, I was going to say, now that we've seen what happens if you hadn't saved recently, now once you
I got everything.
save everything, that would be a good time to save.
Yep.
Okay, let me know when you're ready, and then we'll proceed. Did anybody else's have that same problem, or was it just mine and James's computer?
All right. Shoot. It's weird because it saved some of it. Like I had my coin set point was saved, and I was in the middle of renaming my heating, and some of it saved it and some of it didn't.
Yeah, all the programming that resides in the controller itself in terms of the instances should all have where you left off. It's the graphical programming that didn't get saved on your computer and didn't get saved in the controller, because that part only happens when you click the save disk icon. So generally a good idea once you've finished a substantial part of programming to hit the save button so that if something does shut down when you restart it, you'll be able to pick up where you most recently saved.
It's actually rebuilding it pretty fast. Actually, some of the things that were connected are reconnecting back.
Yeah, because the lines will draw based on the connections that it sees in the controller, and those didn't change. Again, it's just the graphical representation of the program really didn't get is the part you have to rebuild. Yeah, once you drag the appropriate icons back out on the screen, it should, again, rebuild pretty quickly, as you've seen.
When you pulled that second logic up to the other one, what did you want me to name that again?
Fan status is the analog comparison, and check RAT fault is the binary comparison.
Yeah, but when I pull up the second, that logic right there, it pulled up a different.
Here, let me let you share your screen, and then you can show me what you're working on.
The IMP004. I must have did something wrong.
Yeah, okay, so that's the link should already be there, but if you want to reestablish it, then you want to pick the fault status. So you need to scroll down just a little bit on the right.
Oh, that's right.
So
fault
there
status.
It is. Fault status.
Yep. All right.
Okay, so you got AVs, you got sequences. And you'll want to drag your outputs out there too, the cooling and heating outputs further to the right.
That might have been the two things I haven't added yet to it, so I still haven't.
Yeah, so go ahead and hit save now. Yeah, hit the save icon just since you've got back to where you were. And now pick the output object from the objects box. Oops, looks like it disappeared, so you got to right click.
I just saved it, yeah, and then where is it at?
Right click on the right side of the screen, not the left.
That's right.
And you can generally leave that objects box visible. You don't, most of the time I don't close it. So then cooling 1 and 2 up near the top right. And then in your case, W1, W2 down below.
Sorry
it would also be a good idea. Yeah, that's fine. It'd be a good idea to name your logic. So the analog logic type, that one I named as fan status. Excuse me.
What did I do wrong then? Because I had cooling set point. All right.
Yeah. So you can rename that one as fan status. You might want to make the screen bigger. So
I've got my screen split in half so I can watch you and do what I'm doing at the same time.
I got you. Okay.
So fan status.
And then the other logic I named check RAT fault.
What was it? Check what?
RAT for return air temp fault. Okay, and then go back to the graphical program. So I think that's pretty good. And so where I had left off was, let me make myself the presenter again. Screen share.
And that hysteresis was 20 on the fan status, correct?
Yes.
All right, thank you.
So where I left off was editing my heating set point. So I'll go to my lower analog value properties. I'll give it a name like heating SP. I'll choose the scaling option with a factor of 0.01. Confirm that the real value has the decimal in the correct location. And in the backnet units, click type D until I see degrees Fahrenheit. And also on the backnet alarm and COV tab, that's where that COV increment, I can put in a smaller number if I want to see the value update on the front end anytime it changes by that incremental amount. So then I can take the cooling set point and link it to the reset handle of the upper sequence, and I can take the heating set point and link it to the reset handle of the lower sequence. And now we'll, actually I can connect the number 2 output from the upper sequence to cooling 1, the number 3 output to cooling 2. And just to remind myself that I'm reserving the first stage for economizer, I can put in a little small note so that it will remind me, oh, how come I didn't link to output number 1? So I could do a right click, small note, and just type something like reserved for economizer, and then we'll handle that when we do the economizer programming. On the lower heating sequence, I can take output number 1 and go to heating 1 and take output number 2 to heating 2. And then I can go to the properties for the upper cooling sequence, and we can learn a little bit about that. I'll just maybe click save here. Now I'm a little more sensitive to that since my program shut down earlier. So I'll go to the upper sequence properties, and I'll give my sequence a name like cooling SEQ. And then there's the index enable box. I'd already set that to yes in the graphical programming view. Reset enable means am I using the reset handle? And I am, so I should set that box to yes.
Hey, Mike, how'd you make that output one on the cooling for economizer?
I just put in a small note, right click, insert small note. So it's just a little text note I put in there to remind myself that I need to connect that later when I do the economizer programming. In the slide, if that's what you're looking at, this little brown box, we'll make that when we do the economizer program. So for now, I just put a placeholder in with the small note text. So there's also in the sequence properties, there's an interlock enable checkbox that you should set to yes if you have connected the interlock handle, which I have here, INTLK. So I need to put a check in the box for interlock enable. So when I enabled the reset function, the reset tab appeared. When I enabled the interlock handle appeared. There's two checkboxes for Cascade that you'll probably never use. Each sequence instance can control up to 6 stages. There are some very rare cases where you're going to control 7 to 12 stages, or people have needed to control 7 to 12 stages. And that's where you can use 2 sequence instances kind of in tandem to control 7 to 12 stages. And that's, again, a rare case. So almost always both these Cascade options you'd leave at no.